Hello everyone, I would like to continue providing the videos for topic 3 homework help, and then if you want to, you can continue working, finish all of this assignment as quick as possible. So next one is the homework 3, topic 3, find the population mean and the sample mean as indicated. So opening the StatCrunch, and you have the data available here. So stat, summary stats, no, I need the data, no, stat calculators, no, summary of stats, tables, summary of stats, okay, summary of the stats, columns, right? So now what I do, I choose this variable 1, and then you see, if you scroll it down, you can see mean, variance, standard deviation, standard error, median, range, and you can see it's the population mean. Population mean is unadjusted variance, unadjusted mean, so mean is the same. So there's nothing wrong with it. The mean will be the same, and you can choose the mean is the same, so you just compute the mean value, so it's 10. Next question. It says what? For large sport event, 67 for revenue. Mean, what was the mean price per slot? Okay, 67, 165. So you think you just divide it. 165 divided by 67. 1.4. 2.5. Okay. So next one, the x mean value and median should be here. So from a histogram where the mean is greater than less than approximate median justify answer. Median should be less than the mean value because most of the data is here. The mean value is around here, but the median is in the middle. So mean value is bigger than median. No, mean value is bigger than median. Symmetrical, no. Okay, mean is for a histogram on the right. Determine the mean is greater than, less than, or approximately equals median. X bar, this is skewed to the left. That's for sure, skewed to the left. Okay, so skew left, not equal. So if it's skewed to the left, is this one. Right, so the mean value is smaller than the median. The median should be here. The mean value, because this is too small. Okay, so I think it should be okay. It's fine, but you know this is skewed to left. Okay, and next one. Click the data, view the table. They have the table here, and continue mean, median, and mode for that. So you open that in the StatCrunch. Okay, so it asks you for table A only. So table A. So now we do sum of stats, columns, table A. And it asks you for the mean, median, mode. Okay, so I can do that. Mean, control, median, mode. Control. Okay, I select the mean, median, and the mode. Compute. This is the mean value. 1000, so 72.22. And the median, thousands, so it's going to be this. Okay, so the mode, for type, the mode pH is this. Okay, for the bottom water, the mean of pH. Okay, so which means I have to do it once again for the water, the bottle of for bottled water. Okay, bottled water. Oh, this is still for A, so I just choose the bottle A. And the summary stats, columns, choose the water, and mean value. It only asks you for mean value, so I just do mean value. Continue, 5.25. Okay, it asks you the median. I have to do it again. So choose the median. Control goes down, median here, and I want to choose the mode in case it asks you as well. So median is 5.225, and they ask you for the mode. It's 5.26. Okay, so the B, if the pH, suppose the pH of 7.1 incorrectly recorded is 1.7, as seen in the table B. So the table B, everything is right except this one is wrong. Okay, but you ask you for the mean value, everything again. So just choose that columns, choose the table B. In case they ask you for everything else, we do that as well. Choose the mode, mean value, and the median. Median doesn't change. And so what property of the median does this illustrate? It illustrates the median divides 50%, 50%. It illustrates the residence of mean. It does not illustrate any property of median. It illustrates the residence of, so it's going to be 50% up, 50% down. But wait, property of median does this illustrate? The residence, it illustrates the resistance of mean value. It does not illustrate any property of the median. Okay, let's see the median. The median does not change. It illustrates the resistance of the mean. What does this illustrate? The median. Oh, a resistance. It illustrates the resistance of the mean value. It does not illustrate any property of the median. Instead of the resistance of the median. It should be this one. Okay. So next one, let me see. It should be very simple. You copy in the StatCrunch. Wait. So you can directly open this in the StatCrunch. And what you can do, you open the StatCrunch. You ask the graph, histogram, graph it, and check histogram, right? And variable 1, compute. Which one? This one. Okay. Skew to the right. And the mean weight of that, which is just do stat. And tables, no, summary stats, columns, choose the first one, and then go down, go to the mean value. 0.838. Okay, the median. Let's go back and check that median part again. So it's going down for median. In case it needs the mode, I just include that. So median is 0.83. Okay, which measure of the center tendency best describe the weight of the candy? The center tendency. The median, or it's not going to be the mode. It's going to be either median or mean value. I think the center position is the median. Okay. So next question is pretty much the same as the previous one. Let me see if there's anything else. So data discrete or continuous. This is obvious. The discrete is not continuous. Is not measurable. It's countable. Okay. You can graph that. It's pretty simple. You can open that in StatCrunch, and then graph, histogram, check, compute. So you have this like this. It's going to be this one. Skew to the right. Skew right. Okay, so the mean should be substantially larger than the median. The mean value should be here. Median. Frequency is this. Median is smaller. Okay, so median is smaller. Mean should be larger than median. Okay, the mean value is what? So what do we do? You can check mean value clumps. In case they ask you for everything else, I'll do mean value, median, and mode together. So mean value is 0.861, 2.86. And also the median is 1. And ask you for the mode. The prediction is, what do the computer mean and median tell you? Fill the blanks below. Okay, you're going to do that yourself. Okay. Find that. So next one, population variance and standard deviation. You can do the same thing. Open the StatCrunch. Okay, so if it says you do summary stats, column, choose this one. If it says population variance is not this mean and this variance, because this is sample mean and sample variance. You have to scroll it down to unadjusted variance. Unadjusted variance is population. It's going to be the population variance. Unadjusted standard deviation is population standard deviation. So it asks you for unadjusted variance is 64. And the standard deviation is going to be 8. Square root of 64. Okay, this is a sample variance. So if it's a sample variance, what do? Open the StatCrunch and a summary columns, variance, variable 1. Sample variance is just the sample to regular variance. Just click variance, compute. You have the variances like this. 2 decimals. Okay. And standard deviation, I didn't choose a standard deviation, but I have to choose a standard deviation. Is this one, compute 10, so it's 13.1. Okay, so this you can try that by yourself. The range, okay, so the range is, you click the data summary of A, right? So columns A. If you ask you for range, you can scroll down. Range is here. Range is maximum minus minimum. The maximum value is minus the smallest value. The maximum value is 2.5. Small value is 0.0. So the range is 2.5. Minus 0 is 2.5. Range for B, 1.5 is the biggest one. Smallest one is 1, so it's 0.5. Okay, standard deviation. You can use the StatCrunch to do that. Columns A. And then just choose B or both of them. Choose a standard deviation for both of them. So standard deviation for the first one is nearest to cents, 0.93 cents. We got $0.93, actually 93 cents. B is 22 cents, $0.22. Okay. That's it. So next one, have not continued, finished yet. Okay. So which city has most dispersion based on the range? A has it. A has higher range, so it's more dispersed. Which city has most dispersion based on standard deviation? A. Larger, higher standard deviation. Okay, standard deviation, which is pretty simple. Just open the StatCrunch and summary stat columns, choose it, and the standard deviation, choose standard deviation, compute, and that's your standard deviation. 2 decimals. and you have the graph, the histogram. The histogram is bell-shaped, so it is bell-shaped. It's like a bell. And use the empirical rule to determine the percentage of the candidates weights between that hint to that. Okay, so this is the 1/4 of the range, the empirical rule. Okay, so you can use the there's a formula in the book. Find the formula and do this. It should not be a big problem. Okay. If you don't know the formula, go back to the D2L book. It has a formula for the empirical rule to determine the percentage of the candidates weight between this. Okay, so it's not really hard. I can't do that with the software. I don't think so. So next one will be between a weight of that. Use the empirical rule. Okay, you can do that by yourself. It's a pretty simple formula. I want you to check it by yourself. Alright, so next one. Okay, this one asks you for finding the z-score. Okay, so there's another formula for the z-score too. Minimum score. It should be pretty simple. The median of the variable x is in the middle, so it's 30, 40, 50. Okay, the third quartile in the variable y is going to be, this is median, I think it's 40, 30, 40, 50, so it's 40. No, it's not 40, so you have to, let me say, it depends on, this is your median, 30, and between these two, this is 50. Nearest integer was the third quartile of the variable y. Okay, so 30 subtracted. No, it's not 50 because it's past the 50. You can do that, check that by yourself. It's not really hard. Okay, so this is a topic 3 assignment. Okay, you can try that. Let me see. In the StatCrunch. You can graph it, box plot, variable 1, compute. Okay, it's like this, but you have to do another way around. But you can see it's in this way. So it's going to be from 0.85 and kind of in the middle. Let me see if I can change that way into horizontally. Okay, so now I think it's pretty much like a C. Okay, is this distribution symmetric? I would think it's symmetric. Okay, so you can finish this homework. I don't see anything really difficult. I have introduced. Use the software to help you find the mean value, standard deviation, mode, draw the histogram graph. Okay. If you have questions, just let me know. I can explain that to you again.